The La Salle University is the seventh most populated university in the Philippines with an enrollment of roughly 13,000 students. Sometimes during the rainy season, the administration has been canceling classes during class hours already. We are to integrate this scenario with the La Sallian population to come up with an interesting first-order differential equation.
The problem now is this. Suppose that the administration announced to 20 members of the university student government the suspension of classes at 9 a.m. And assuming they have disseminated this as soon as possible, the rate at which the announcement is disseminated is proportional to the number of people who knew it. If at 9:20 a.m., 4,000 students have already known about the suspension of classes, what percent of the population is yet to hear the announcement? Based from the problem, it is given at time equals 0. There are 20 people who are disseminating the suspension of classes. Hence, we now have this notation. After 20 minutes, the information has been heard by 4,000 students. The question asks to find the percentage of students that have not yet heard the announcement. To solve for this, we need to find the number of students who have heard the announcement first. This is defined as x at time 60.
In this problem, we're going to use a new approach. This is called the logistics equation. Now, the logistics equation is used when there is a maximum capacity in a certain population. The differential equation is dx over dt is equals to kx times quantity 1 minus x over m, where x is the total population at any time t, k is the proportionality constant, and of course the m is a constant which equals to the total carrying capacity of a certain population. The logistics equation has been proposed by Pierre Verhulst to overcome the deficiency offered by the conventional exponential growth differential equation that is given by y is equal to kx. Notice here that the population increase is still proportional to the number of population at a given time. But notice also that there is a mortality curve which dominates when the population is high. In this case, the total carrying capacity is m, which is equal to 13,000. That is the population of the LSU at school year 2012-2013. The logistics equation is a variable separable type of differential equation. Now we're going to solve x and t analytically. So we're going to have dx we are to simplify this term by the LCD m. This equation can be solved by partial fraction now. Integrating both sides will have ln of x minus ln of m minus x, which is equal to a plus c. Because we're talking about indefinite integral, so we'll have to put an arbitrary constant. So simplifying this further, we'll have now multiplying both sides by negative 1 will make our lines easier to solve for x. So m minus x over x now is equal to e raised to negative at e raised to negative c. Notice here that e raised to negative c is also a constant. So we may write a variable a. So we let a now equals e raised to negative c. Now the equation now becomes m minus x over x is equal to a e to the negative a. Isolating x now will have x is equal to m or over a e raised to the negative a plus 1. So now we have a function for our x term now. We'll have to solve now for a. If we let a condition x at time 0 to be x sub O will now have m minus x sub O all over x sub O is equal to a raised to negative a times 0. So this term becomes 1 and we are left with a is equal to m minus x sub O all over x sub O.
So using the equation derived earlier, we now substitute our values for x and at t is equal to 20 and x equals to 4,000, we now get our a, which is 649. Substituting again, x 30,000 is Rm, 649e raised to negative 20k plus 1. So manipulating the equation, we now get 649e raised to the negative 20k is equals to 13 over 4 minus 1. So e raised to negative 20k is equals to 9 over 2,596. Using ln, we now get the k equals to ln 9 over 2,596 over negative 20. So our k now would be 0.17. So what t is equals to 60, we substitute it. X is equals to 30,000 over 649e raised to negative k plus 1. So 13,000 all over 649e raised to 60 times 0.17 or negative 10.2 plus 1. We now get our x as 12,694 students. So 12,694 students is not yet our answer, because we're asked to find the percentage of students who doesn't know yet the suspension of classes. Substituting 13,000 minus 12,694 all over 12,694 times 100%, we now get the value of 2.41% of students who doesn't know yet the suspension of classes.